Good morning, friends. Welcome back. Let us learn today the most important concept, the most beautiful concept, and people speak it as the most complex concept of C language. And that concept is none other than pointers. What do you mean by pointers? We'll see it in detail. And to make it clear in a single line, 1972, the advent of C has begun. 2018 today, the journey of 46 years, still in the market C is found because of this concept. We have learned that using C language, we develop system softwares, we develop application softwares. But the beauty of C, the concepts of C are mostly used in developing system softwares, mostly device drivers. And that has become possible because of this concept pointers. Okay. So before we go into the concept of pointers, let me start with a small example, a very small example. Fine. So the example starts like this. So when I say int x is equals to 5, int x is equal to 5, assuming a 16-bit environment, assuming a 16-bit environment, right? On a 16-bit environment, x takes 2 bytes. 2 bytes. So 2 bytes indicates 16 bits. 16 bits. So internally 16 bits, right? So 5 is 1, 0, 1, 3 bits, and the remaining 13 bits will be zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 zeros and 101 is 5. So total is 16 bit. So this is where we start with. When I say int x is equal to 5, this is some data form. And so when you say int x is equal to 5, the compiler looks for 2 bytes which are free enough. So assuming that my compiler found 2 bytes which are free enough. Address of byte 1 is 2050. Address of byte 2 is 2051. And we need to store this data in this, and this 2051 are associated to x. So internally it is 1, 2, 3, 4, 5. This is how we store 5 internally. And you find 2050, 2051, right? So 2050 is called as the base address. So this can be represented in a simpler, better form so that all of us can understand. So 2 bytes, I call it as byte 1 and byte 2. I call it as byte 1 and byte 2. And this will be your x. And I always term my data location with the base address. And this is your 5. And this is your 5. Okay. So let me follow this notation instead of this to make things simple, easy for you. Now with respect to this, let me write few lines. What is address of x? Address of x is 2050. I always refer the address of x with respect to its base address. Though x has 2 bytes, it is 2050 and 2051. We always refer the address with the base location only. And when I say value of x, what is value of x? The value of x is And if I say the word value at 2050, what do you mean by value at 2050? Value at indicates the value present at this location 2050. So value at 2050 is 5. In fact, so value at this 2050 is nothing but address of x. So address of x is 5, right? And I can write this value at by an operator is 5, right? So from this we say that x is same as value at address of x is same as 5, isn't it? True or not? Should be true. Address of x is 2050, value of x is 5, value at 2050 is 5, and value at, I write 2050 as address of x is 5, and value at has got a symbolic notation asterisk. So value at address of x is 5. So from the second line and the last line, can I equate that x is same as value at address of x is 5? Now from this conclusion, I can refer 5 by its name, the location name. I can refer 5 by the location address. If this is my physical location, I can refer the value present in that location by its name and by its address. Location name is x, location address is 2050, isn't it? So 5 is accessed by name. What name? These 2 bytes location name, and the same 5 is accessed by 2050. So this is called as addressing 2050 to get the value present at that. So pointers is all about handling the data based on the location address. The concept of pointers deals with handling data present at a location by its address, not by its name. Regular things, we handle data by the location name, but with respect to pointers, we handle data with respect to the location address. So location is 2 bytes of the location name, location address. Fine. So the question starts here. What is a pointer now? What is a pointer? A pointer is a variable, a regular variable with a small difference. The difference is a regular variable stores regular values, whereas a pointer variable stores the address values. Why address values? Because I told you that we are concerned with handling the location value by its address. So pointer is a variable that stores the address of another variable of its own type. Of its own type. So before you write all those things, just heading as pointers, copy down these things clearly. Done copying that? If I done copying that, then let us go to the definition of pointers. So what is a pointer now? You've done. A pointer is a variable that stores the address of another variable of its own type of its own type. Without that last three words, the definition becomes incomplete. Of its own type, right? So in this story, so this is my location, my physical location, right? And location name is X, location address is 2050. Location address is 2050. Second point. In pointers, we are concerned with handling the data based on the location address. So how you declare a pointer? The declaration part. The data type, the asterisk symbol, and the identifier. Data type and the identifier. So example, int pointer p, float pointer x, char pointer x. So examples. So pointer variable. Okay, please copy it down carefully. Done copying that? And note point, this symbol asterisk is called as indirection operator, or also called as value at operator, also called as value at operator. Please, asterisk is called as indirection operator or value at operator. If you're done with this, then we'll go to the next line. Yes. the same int x is equal to 5, right, and int pointer p. So what happens internally? So internally, x takes 2 bytes, some 2050, and the value of x is 5. Clear? And then now p is also a variable. Assume the address of p is 3050. It's of 2 bytes. It is of 2 bytes. Now x is 5, initialized p, and then I say p is equal to address of x. I say p is equal to address of x. So what do you observe now? We observe that this value 2050 is copied here. It is 2050. Is 2050. Fine. Now from this box we observed that the value of x is same as value at address of x is same as 5 from this box. Accepted? Should be accepted. Now can I write my pointer x, address of x as p now? So it means that my value at p is 5. What did I do? Nothing new. I replaced my address of x with the value of p. Now 5 is x. 5 can be handled by value at address of x. 5 is handled by pointer p. Now what am I doing? I am handling 5 by using the location name. I am handling 5 by using the location address. In fact, these both are one and the same. Yes or no? So pointers is all about handling the data by the location address. The point was given to you, right? So please copy it down. Copied that? Right? Right. Now, when you work with pointers, try to identify the regular variable and the pointer associated to it. What am I trying to tell you is, if you can identify the regular variable and its associated pointer variable, then we can interchange them on requirement. What do you mean by interchange them on requirement? Now in this case, int x is equal to 5, int pointer p. This is the relation between p and x. When this is the relation between p and x, then it means that pointer p is same as x. Yes or no? When pointer p is same as x, wherever I get x, I can replace that x with pointer p, or wherever I get pointer p, I can replace pointer p with x. Yes or no? For example, I have a code like this: x is equal to x plus 5. Now can I replace this x is equal to x plus 5 with pointer p is equal to pointer p plus 5? Or if I got pointer p is pointer p plus 5, can I replace that with x is equal to x plus 5? I hope it makes sense. So whenever you are dealing with the problems related to pointers, as a student, your first task is identify the pointer variable and its associated regular variable. Once you find the associated regular variable, then problem solving becomes very simple. For example, assume that I got a code like this, like int a is 5, int b is 10. This is some pointer pa and pointer pb. I say pa is address of a and pb is address of b. Then I got a code like this. A code like pointer pa is pointer pa plus pointer pb, and I got pointer pb is equal to pointer pa minus pointer pb, and I say pointer pa is equal to pointer pa minus pointer pb. I got this code. So for a regular student, seeing this type of code seems a little weird, isn't it? All pointers involved. Then how to solve this code without getting confused? Now, in the given problem, you observe that PA is address of A and PB is address of B. If PA is address of A, then it means that value at PA is same as A, and if PB is address of B, it means that value at PB or pointer PB is same as B. So now can I replace this code with PA is A, right? So it becomes A is equal to A plus B, B is equal to A minus B, A is equal to A minus B, which is a better problem solving aspect with respect to pointers. This will not make you feel weird, but this will make you feel weird, right? Isn't it? So whenever a pointer variable is given to you, try to identify its associated regular variable, and while problem solving, try to switch the pointer variable with its respective regular variable so that the problem solving becomes easier. Take a note point. Note point, please. Yep. For a given pointer variable, comma, find out its associated regular variable. Find out its associated regular variable so that we can replace the pointer variable by the regular variable for easier problem solving. Take this and that, please. Done copying this? Yes. Now, now, heading as pointer initialization. Heading as pointer initialization. What do you mean by the word initialization? Initialization is a procedure of assigning the value to a variable at the time of its declaration. Take it down, please. Initialization is the process of assigning a value to a variable at the time of its declaration. Now, what do you mean by that? So, I say int x is 5. I say pointer px, and this is called as px is address of x. This is declaring, and this is assigning. So declaring is one step, assigning is a step. So take int x, it should make sense. Int x, pointer px is address of x. Now, instead of that, if I can write it in one line, int x comma pointer px is equal to address of x. Int x comma pointer px is equal to address of x. So this is called as initialization. I'm initializing address of x to px at the time of this declaration. So please don't get confused. Sir, here you wrote px is address of x, here you wrote pointer px address of x. Yes, this is possible when you take a separate line, and the first part is it declares pointer px. The compiler will assume that px is a pointer variable, and when I say pointer px is address of x, it takes px is address of x, and this happens only when you initialize it. So please, this is same as this. Okay, please copy it down. Please copy it down. Right? So this is called as initialization. Assigning a value to a variable at the time of its declaration. Fine? Yeah. Now, let us go back to the first line. The first line says, a pointer is a variable that stores the address of another variable of its own type, isn't it? Now let us come back to that. I say int a pointer x. I say float b, I got pointer y. And I say char c, I say pointer z. Int a is pointer x, float b is pointer y, char c is pointer z. Now, based on this, we write few points. So if I say x is equal to address of a, is it valid? X is a integer type variable pointer, and x is an integer type pointer variable, a is a regular integer variable. So I am storing an integer address in an integer pointer, valid. When I say y is equal to address of b, I am trying to store a float variable address in a pointer variable. When I say z equals to address of c, I am trying to store the value of c in z, right? So x is address of a, y is address of b, z is address of c. Is that true? So all these are valid. Why valid? I am trying to store the address of its type. What is its type? X is an int type, I am storing an int address. Y is a float type, I am trying to store float address. Float variable address. Z is a character pointer, and I am trying to store the address of a character variable. Z is address of C. And then what next? Suppose if I try doing x is address of B, or I say y equals to address of C and z equals to address of A. What do you observe? You observe that B is a float type address, x is an integer variable. C is a character type variable address, and y is a float variable. A is an integer type address, and z is a character variable. So this are invalid, and you may get an error called as suspicious pointer conversion. You may get an error called suspicious pointer conversion. Is that fine? Yeah. Suspicious pointer conversion. Few compilers generate error, few generate a warning. The latest compilers generate a warning with this, saying x is address of B. This is called as a warning because you are trying to store an address, but address of not the same type. So please copy it down. Is it fine? Yeah. If that is fine, then we'll go to the next story. Chalo. Int x is 25. Pointer px equals to address of x. Initialization. Now I want to find the values of address of x, address of px. Okay. I want to find x. I want to find px. Okay. So let us draw a small diagram first. This is x, this is px, okay, the location names, and assuming that address of x is 2050 and px is 3050, x will be 25, px will be 2050. Okay, for this notation, what do you get? So what is address of x? 2050. What is address of px? 3050. What is x? 5. What is px? 2050. Right? Nothing new. Now the question is, what is the value at address of px and what is the address of value at px? What is the value at address of px and what is address of value at px? Now from this story, address of px is 3050. So it is address of px is 3050. So what is address of px? 3050. So what is value present at 3050? It is 2050. So the answer is 2050. Clear? Now I have been shouting that whenever you have pointer variable, if you try to find its associated regular variable, then it becomes, I can replace pointer px with x, right? Sir, why x? Because value at px is address of x. So we can write that pointer px is same as x, the previous examples. So what is address of x now? Right or wrong? So please copy it down. I am trying to solve the problems with respect to my data, 2050, 3050, right? If I am done solving these two, let us solve these two also. Okay. So value at address of x. So value at what is address of x? Address of x is 2050. So this is nothing but 25, isn't it? Value at 2050 is 25, and this is same as value at address of px. So address of px is 3050. So what is value at 3050? It is 2050. And what is value at 2050? That is 25. That is 25. So different notations given to test you. It says in the exam, it says printf %d value at address of px. The answer would be 25. Answer would be 25. Right? So please copy it down. please. Is it fine? Yeah. Shall I? Now the next story will be size of pointer variable. The next story will be size of pointer variable. This is a little interesting story to learn. Why? Now basically, why do you use a pointer variable? We use a pointer variable to store the address. It can be address of an integer variable or address of a float variable or address of a character variable. Integer pointer stores address of integer variable. Float pointer stores the address of float variable. Character pointer stores the address of character pointer. The common word is address, right? Address, address, address. So, sorry. On a 16-bit environment, address size is 2 bytes, and on a 32-bit environment, address size is 4 bytes. So 2050 is a 16-bit data. 16-bit is 2 bytes, isn't it? 3050 is a 16-bit data, which takes 2 bytes. So on a 16-bit environment, address size is 2 bytes. On a 32-bit environment, address size is 4 bytes. So please take this point. We have something to learn. Yeah. Let me teach you the concepts with respect to 16-bit environment. Let me call it as a 16-bit environment. Fine. The same example. I say int x is 25, pointer px is address of x. You got that. Now when I say float y is 25.5 and pointer py is address of y, and when I say character c is some a, and when I say pointer pc is address of c, what happens? So let us see what happens. It creates y. Now y is of size float. So float takes 4 bytes. Byte 1, byte 2, byte 3, byte 4, or anything. Call it as now C takes 1 byte. C takes 1 byte. Now let me speak of your PY and PC. Now the question is, how many bytes does PY take? How many bytes does PC take? Isn't it? So assume that the base address of Y is some 4050 and this is some 6050. Now I store something called as 25.5 here and I store something called as A here. Right? Now, what should a pointer store? A pointer should store the address. Address is 4050 and address is 6050. And basically 4050 is a 16-bit address. It is a 16-bit address and 16-bit is 2 bytes. So PY will be 2 bytes. 6050 is a 16-bit address. So the size of PC will be again 2 bytes. So what I am trying to tell is, whether it is an integer pointer or a float pointer or a character pointer variable, the size of a float pointer variable will be same as the size of integer pointer variable will be same as the size of character pointer variable. So this is some 5050, some 70. So let me write some points. Size of int 2 bytes with respect to 16-bit element. Size of float 4 bytes. Size of char 1 byte. Size of int 2 bytes. Size of float 4 bytes. Size of char 1 byte. Now, size of integer pointer. Size of float pointer. Size of character pointer, or size of double pointer, whatever you call it, will be 2 bytes. Will be 2 bytes. Sir, why it is 2 bytes only? Integer pointer or float pointer or character pointer or double pointer? Why it is not more than 2? Why it is not 4? Why it is not 1? Why it is not 8? Because we use pointer variables to store the address and not the value. And address has got a fixed size. Address has got a fixed size. So pointer variables also have got a fixed size. So take a point. So take a point. As the size of the address for any variable, for any type of variable is the same and as we store the address values, in pointer variables, and as we store the address values in pointer variables, the size of a pointer variable, the size of the pointer variable of any data type will be the same. So int float char is 241, but int address is 16-bit, float variable address 16-bit, character variable address 16-bit, double variable address 16-bit, long double variable address 16-bit. So when you are storing the address, that pointer size will be constant. So take the example. Yeah, so if this is fine, that's for now. In the next session, we'll see more about pointers. Fine. Thank you.